Hey, physical science, it's Wednesday, May the 6th, and we're having a good time now. Look on page 561. Make sure you got this thing with you. Maybe it doesn't look like that. Maybe it looks like this. Maybe it looks like the back of your book. But either event, you're going to need a periodic table. We're going to talk to you about multiple covalent bonds on page 561, right there in the middle. Covalent bond means you got a non-metal, non-metal. And so let's take some oxygen. And oxygen is element in group 6 right here. They call it 16, I call it group 6. So let's give it 6 dots. 1, 2, 3, 4, 5, 6. I'm putting the notes. I'm putting 5 and 6 on the back side because I know where I'm going. And here's another oxygen. And it's 1, 2, let's put it down here. 2, 3, 4, 5, 6. And this oxygen says, hey, brother oxygen, I have 6. I need 8 to have a stable octet in my outer energy level, which would be the second energy level. And so I'm going to need 2 more. Could I borrow 2 of yours? And the oxygen says, you bet. You can borrow 2 of mine if I can borrow 2 of yours. And this one throws his 2 in there. This one throws his 2 in there. So this one is happy. He now has 6 of its own and 2 of his for a total of 8, stable octet. And they overlap their electron clouds and they lock together like this because they have overlapping clouds. And the way we symbolize that is we go oxygen, double bond with oxygen. That's a tighter bond. It's closer together. It's harder to break. And it's the reason we say diatomic. There are 7 elements that are diatomic elements. And I've listed them on the back of my periodic table right here. And I'll tell you which ones they are. They are hydrogen from over here. There we go. Hydrogen over here. And then starting with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Hydrogen and around the corner, not to include noble gases, but around this corner right here. 7 diatomic elements. What does that mean? That means if they are connected with a different element, it's okay. But if they're connected with nobody, they're by themselves, they will need a buddy. They have to have a buddy. And so if they don't have a different buddy, they buddy up with one another. And oxygen is that way. Carbon monoxide is okay. It already has a buddy. But if it's 2 oxygen atoms, they combine like that. That's a molecule. That's a molecule of carbon monoxide. This is the carbon dioxide, carbon dioxide. Okay, those are all, we call them molecules because they are covalently bonded, and they're covalently bonded means that they share electrons, and it also means that they are non-metal, hooked to a non-metal. One of these yellow ones hooked to one of those yellow ones. What does non-metal mean? It means it is not a good conductor of electricity. It can't flatten and become malleable. It has, it doesn't have all the characteristics of metals that I just described. Okay, that's page 561. Now we're going to go on over and hook these things together. Page 565, chemical formulas. We're going to use oxidation numbers to write chemical formulas. Look on page 565. An oxidation number is a positive or a negative number that indicates how many electrons an atom has gained, lost, or shared in order to become stable. Page 566, look at the top. Isn't that exactly what I had you do in the back of your textbook? Write in a +1 here and a +2 there, and skip these transition elements and put a +3 on this group instead of a 13, and skip 14 and go to 15 and put a ooh, That's put a 5 there, which is a -3. And put a 6 here, which is -2. What does the -2 mean? -2 means that this has 6 electrons in its outer energy level, everybody in that group, and they want 8. So when they gain 2 electrons, they get a charge of -2. Some call it an ionic charge, and some call it an oxidation number. But put a -2 there, a -1 there, and a 0, of course, for the noble gases, because they don't combine with other elements. Those are oxidation numbers, which we used to call combining capacity. It's capacity to combine with other elements. Okay, look on 566 at binary compounds. How many wheels does a bicycle have? It has 2 wheels. So binary means 2. It's compounds made up of 2 different elements. When I said carbon dioxide, that is a binary compound. It has 3 atoms in it, but it's a binary because it has 2 flavors, carbon and oxygen, 2 different elements. I call them flavors. All right, so we're going to make binary elements. Now, you'll notice that table 2 says there are some metals that have more than one oxidation number. They lose different numbers of electrons. For example, looking at table 2 on page 566, copper can lose 1 electron or it can lose 2. So a +1 or a +2 oxidation number. Iron can lose 2 electrons or 3 electrons. But don't forget, those are metals. So therefore they are losers. Metals are losers. Non-metals are gainers of electrons. And then chromium is a +2, +3. Lead can be either a +2 or a +4, depending upon the compound. So I'm on example problem 1. It says formula for lithium nitride. Lithium nitrogen. Now, if it is a binary compound, which this is, it has 2 flavors, then we use the IDE ending. So we don't call it nitrogenide, we call it nit. We take the stem, might call it the prefix, stem, nit, and give it the IDE and, oh, nitr, well, as in nitrogen, nitride, nitride. Lithium nitride is lithium and nitrogen. Finding it on the table is the hardest part. You're taking a word and you're trying to find a symbol. You're taking a word and trying to find a symbol. And the 2 symbols are lithium and nitrogen. Okay, Li and M. Now, if you go above lithium, you'll see a +1. I want you to write a +1 right there. And above nitrogen, you're going to see a -3. I want you to write a -3. I want you to ignore the sign, the SIGN, ignore the sign, and put the appropriate, you might call it absolute value, of that number down there. If it's a 1, you don't have to write it. It's understood to be a 1 if there's nothing there. And a 3 goes down there. We call it the Crissy-Crossy method of writing formulas. So the answer is Li3N1, and the 1 is invisible. That's the formula for lithium nitride. See how easy that is? And what does that mean? That means that I have 3 lithiums at +1 apiece and 1 nitrogen at -3. And what is +3 plus -3? It's 0. If it's a properly written formula, it is going to add up to 0, the oxidation numbers. So if you do Crissy-Crossy, it works every time, except if you can reduce it, you've got to reduce it. What does that mean? That means this. I want the formula for magnesium oxide. Okay, magnesium oxide is Mg for magnesium, O for oxygen. Okay, And magnesium on this table here is +2, and oxygen is -2. And so when you crisscross this thing, you're going to put a 2 down there, and you're going to put a 2 down there. Forget the sign, just put the absolute value, the number. Okay? Now, can 2 over 2 be the same as 1 over 1? Yes. So the real formula is MgO. So if you can reduce it, you have to reduce it. Can you reduce 3 over 1? No. So you leave it the way it is. So crissy-crossy works every time. Is this an ionic or a covalent bond? It's ionic because it's a metal lithium, a bluey, it's over here, with a non-metal. That's a yellowy. And magnesium is a bluey, and oxygen is a yellowy. And so it is what we call an ionic bond. Well, I thought lithium was supposed to have brackets around it with a +1 next to it. Well, that's true. But once you put it in a formula, you don't use brackets, you don't use the charge. The charge is simply the way of getting to the formula. Once you get to the formula, you can erase all this stuff. And you don't use this. That was just part of the understanding of what we were doing with ions. And so this is an ionic bond. It's a metal with a non-metal. Electrons are being transferred from the lithium onto the nitrogen. And each lithium has loses one electron because lithium is in group 1. It has one dangling electron to give away. And so you need 3 of those lithium atoms to satisfy a nitrogen, because a nitrogen wants to gain 3. So it has 5 in its outer energy level. It wants to get 3 more to become like neon. Okay, so let's go to number, well, let's go down to number 16. Practice number 16. What is the formula for lead, Roman numeral 4, phosphide? Lead 4 phosphide. Well, it's going to be Pb for lead, plum bum. You got to go find lead, and you find its symbol. And if it's lead Roman numeral 4, that means it's a +4 variety of lead. If you go look at table 2, you can see that lead is either a +2 or a +4. This time it's a +4 in this compound with phosphorus. Phosphorus is the element P, and it's IDE ending, indicating it's a binary compound. It means 2 elements. It doesn't mean 2 atoms. It means 2 elements. And phosphorus is way over here, and it's +3. I'm sorry, -3. So when you crisscross that thing, the 3 goes down there, and the 4 goes down there. So the answer is Pb3P4. That is called lead 4 phosphide, not that lead 4 phosphoricide, lead 4 phosphide. Okay, is that binary? No, yeah, it is. It's got 2 flavors. Is it diatomic, meaning 2 atoms? No. Is it binary? Yes. It's got 2 flavors. Is it diatomic? No. It has 7 atoms, not 2. Okay, next question. Is it ionic or covalent bond? It's an ionic bond. It's a metal, non-metal. Okay, next question. Do you ever use Roman numerals in a formula? No. Roman numerals only go in the name. This is lead, Roman numeral 4, phosphide, phosphorus, and then the IDE end, phosphide. So that's a good one. Looks like I've been going at it for 15 minutes. I may have to finish this up tomorrow. You know what? I'm going to do that. See ya.